Now let's briefly review parabolas. So let's say if we have the equation y squared is equal to 4px. If p is positive, this graph is going to open towards the right. And it's currently centered at the origin. And it's going to look like this. The focus is p units away from the center. So this is equal to p. And this part is equal to 2p. Now granted, my graph is not drawn to scale, but this is what it is. Now if you go p units to the other side, you're going to get the directrix. Since it's a vertical line, it's x equals negative p if the graph is centered at the origin. The focus have the coordinates p, 0. So keep in mind, if p is positive, it's going to open towards the right. And if p is negative, then it's going to open towards the left. So if this was like negative 4x, it would open towards the left. If it's positive 4x, it's going to open towards the right. Next we have this equation, x squared is equal to 4py. So this one is going to open up and down. I like to see it as y is equal to something x squared, because that's basically a parabola that opens up or down. If p is positive, it's going to open up. If p is negative, it's going to open down. So here is the directrix, and it's p units away from the center or the vertex. And here is the focus, which is also p units away from the vertex. Right now the vertex is centered at the origin. And once you find the focus, to get the curve, basically this point is 2p away from the focus. So once again, it's not drawn to scale, but this is going to be 2p as well, just so you know. Now let's say if the graph is shifted. Instead of y squared is equal to 4px, it's y minus k squared is equal to 4p x minus h. And we'll go over some examples, but if the vertex is not at the origin, this is going to be the equation. If it opens to the right or to the left. If it opens up or down, we need to modify this equation like this. It's going to be x minus h squared, which is equal to 4p y minus k. And the vertex will still be h and k. And we'll talk about how to find the focus and the directrix. To find the focus, since this graph opens, let's say to the right, the focus is p units away from h. So it's going to be h plus or minus p, depending on if the graph is opening to the right or to the left, comma k. Now it's not both plus and minus p, it's one or the other. In this case, if it opens towards the right, it's h plus p comma k. Now if we have a graph that opens, let's say up, and the focus is here, the focus is going to be h comma k plus p, since it's p units above the vertex. So you're either going to add or subtract p to h or k, depending on where the graph opens. So if it opens to the right, it's h plus p. If it opens towards the left, h minus p. If it opens up, k plus p. If it opens down, k minus p, and so forth. Let's try this example. Y squared is equal to 8x. Let's go ahead and graph it. So the equation is y squared is equal to 4px. And for this equation, it can open to the right or to the left. So notice that 8 is equal to 4p. So our goal is first to calculate the value of p. So let's set 4p equal to 8, so we can clearly see that p is positive 2, which means that it opens towards the right. Now the vertex is 0, 0. It's basically the origin. There's no h or k value in this problem. So this is the vertex. Now we're going to travel p units to the right. So that's 2 units away. That's going to be the coordinate of the focus. So the focus, we can clearly see that it's 2, 0. And if we travel p units in the other direction, this is going to be the directrix. We know the graph opens towards the right. It's going to open towards the focus, away from the directrix. So the directrix is x is equal to -2. It's a vertical line. Now, we know this is p. What we need to do is plot a point that's 2p. If p is 2, 2p is 4. So we're going to plot the point 2, 4. And also 2, -4. This will help us to draw a more accurate sketch. So the graph, and I missed the point, is going to look like this. So it gives us an idea of how wide it should be. So instead of drawing something like this, which is basically a guess, we can get a more accurate shape of the graph. So once you have p, the distance between the vertex and the focus, plot 2p. Go up 2p units and down 2p units. And that will help you to get a better sketch of the graph. Now, if you feel dubious about this technique, if you're doubtful, here's how you can prove it to yourself. This point is 2, 4. X is 2, y is 4. And this other point is 2, -4. So using this equation, we're going to plug in an x value of 2, and let's find the value of y. So y squared is equal to 8 times x, and x is 2. 8 times 2 is 16. Solving for y, let's take the square root of both sides. The square root of 16 is plus or minus 4, which we have it here, 4 and -4. So you can also find those 2 points doing it that way. And if you want to, you can plug in another point as well. For example, you can plug in x equals 4 and find the y value here if you want to. But you don't have to do that. You can plug in 3 as well. Let's try another example. Let's say that x squared is equal to -12y. So this equation is in the form x squared is equal to 4py, which means it can open up or down. So we can see that -12 is equal to 4p. Therefore, p is -3. If it opens up and down, and if p is negative, that means it's going to open down. If p was positive, it's going to open up. So now that we have the direction of the graph, we know it's going to open up. And we know that the vertex is still the origin, 0, 0. We can graph it now. P is -3. So p is negative, it's going to open down. If I said up, I meant down. So let's go down 3 units. This will give us the focus. So the focus is 0, -3. Now if we go up 3 units, this will give us the equation of the directrix, which it's a horizontal line, so it's y equals 3. Now to get the next point, if this is p, let's travel 2p units this way and 2p units that way. So if p is -3, then 2p is -6. But let's use the absolute value of 2p, 6. Let's travel 6 units to the right and 6 units to the left. So 6 units to the right of the focus will give us this point, 6 units to the left will give us that point. And so the graph, let's see if I could do this better, should be something like that, and I keep missing it. There we go. It's very wide. And if you want to, you can confirm the points using the equation. So we have the point 6, -3, and also -6, -3. So this time, let's plug in a y value of -3, and let's solve for x. So x squared is equal to -12y, or -12 times -3. So x squared is equal to 36. And the square root of 36 is plus or minus 6, which gives us positive 6 and negative 6 for x. So as you can see, this technique works. It helps you to determine if the graph is going to be wide or if it's going to be narrow. And you just need a rough sketch though, but that's it. Now let's try an example where we have a parabola that is not centered based on the origin. So the first thing we need to do is find the vertex. The vertex is going to be -3, +2. If you're ever unsure, set x plus 3 equal to 0 and find the value of x. It's going to be -3. If you set y minus 2 equal to 0, y will equal 2. Now, we can see that 4p is equal to this number. The general form of the equation is y minus k squared is equal to 4p x minus h, where the vertex is h comma k. So we're going to set 4p equal to -8, which means that p is equal to -2. So whenever we have the form y squared is equal to 4px, this graph opens to the left or to the right. But because p is negative, it's going to open towards the left. So let's go ahead and make a graph. Let's begin by plotting the vertex, which is -3, 2. And now we know the graph is going to open towards the left, which means the focus is towards the left. So p is -2. Let's travel 2 units to the left, and this will give us the coordinates of the focus, which is -5, 2. So now that we have the coordinates of the focus, let's find 2 other points so we can graph the parabola. So if this is p, then we need to find another point 2p units away from the focus. So the absolute value of p is 2. So the absolute value of 2p is 4. So from the focus, let's go up 4 units and down 4 units. So we have another point which is 5, and then 2 plus 4 is 6, and then the other point is going to be, -5, not +5. 2 minus 4 is -2. And now let's draw the graph. So let's say it's going to be something like this. Okay, so now that we have that, let's travel 2 units to the right so we can get the directrix. It's a vertical line, so it's x equals. And the x value is -1. So that's the equation of the directrix. And so that's all we need to do for this problem. Now let's say if you're given the equation of a parabola, but it's not in standard form. Go ahead and put it in standard form and then graph the function. So notice that x is squared, y is not. So let's keep the x variables on the left side, and everything else let's move to the right side. Now let's complete the square. Half of 6 is 3. So let's add 3 squared to both sides. On the right side, we're going to add 9, since 3 squared is 9. And then let's factor. X squared plus 6x plus 9, 2 numbers that multiply to 9 but add to 6 are 3 and 3. So it's x plus 3 times x plus 3, which is the same as x plus 3 squared. -1 plus 9 is +8. So now what we're going to do is take out a -8, which is the GCF. So this is going to be y minus 1. So let's get rid of this stuff. So now we have the equation in standard form. That is, it's in the form x minus h squared is equal to 4p times y minus k. When x is squared, the graph can open up or down. And because of the negative sign, since we have a -8 instead of a +8, it's going to open down. Now, what is the vertex? The vertex is -3, +1, based on these values. If you're wondering how those marks appear, that's just me doing some editing, so don't mind that. Let's go ahead and plot the vertex, which is -3, 1. Now, let's find the value of p. So let's set -8 equal to 4p. If we divide both sides by 4, -8 divided by 4 is -2. So p is equal to -2. Now, we said that the graph is going to open down because we have an x squared. Whenever y equals x squared, it's either up and down. Y equals -x squared, it opens down. Positive x squared will open up. So let's travel 2 units down, and this will give us the focus. So the focus is going to be -3, and then 1 minus 2 is -1. So it's -3, -1. Now let's go 2 units up to get the directrix. And so this is going to be a horizontal line, which exists at y equals 3. So that's the equation of the directrix. Now, if p is -2, the absolute value of 2p is 4. So what we're going to do is, from the focus, we're going to travel 4 units to the right and 4 units to the left. So that will give us 2 points. -3 plus 4 is 1, and -3 minus 4, that's going to be -7. So we have the point 1, -1, and -7, -1. So this is 1, -1. This is -7, -1. Now let's graph it. So this is going to be something like this, and then we're going to have this over here. And so that's how you can graph the parabola. So keep this in mind. It takes p units to go from the vertex to the focus. And if you travel in a perpendicular direction, it takes 2p units to go from the focus to a point on the graph. And knowing that simple fact can help you to draw the parabola with the right size. In this example, we're given the focus, which is 6, 3, and also the equation of the directrix, which we're going to say is x is equal to +2. With this information, draw a rough sketch of the curve and identify or write the equation in standard form. So let's first draw what we have. So the focus is at 6, 3. So x is 6, y is 3. So here's the focus. The equation of the directrix is at x equals 2, which is this line right here. The vertex is in between the equation or the line of the directrix and the focus. So the vertex is here. So therefore, the vertex has an x-coordinate that is the midpoint of 2 and 6. So if you average 2 and 6, if you add them up, 2 plus 6 is 8, and divided by 2, it's 4. So the x-coordinate of the vertex is simply the midpoint of 2 and 6. Now the y-coordinate of the vertex is going to be the same as the y-coordinate of the focus, so it's 3. So the vertex is at 4, 3. And the graph is going to open towards the focus. So we know it's going to open towards the right. Now, what equation do we need? What formula do we need for this type of graph? Anytime it opens to the left or to the right, the y part of the equation is squared. So it's going to be y minus k squared, which is equal to 4p x minus h squared. Now, because it opens towards the right, p is positive. So what is p? P is the difference between the focus and the vertex. So it's 6 minus 4, so therefore p is equal to 2. And We have h is 4, k is 3. So this is going to be y minus 3 squared, which is equal to 4p, or 4 times 2, that's 8. And then times x minus h squared, and h is 4, so x minus 4 squared. So that's the equation in standard form. Y minus 3 squared is equal to 8 times, oh wait, this is not supposed to be squared. So ignore this. So this is the equation. Y minus 3 squared is equal to 8 times x minus 4. That's it.